All right, I'm going to talk a lot about this format, the DAT audio tape. I think it's about my 20th anniversary of like struggling to preserve this particular format. So I'm going to talk about a little bit about my personal history, my relationship with this format, and then like an active research and development project that I'm working on currently. Initially, I went to the Selznick School of Film Preservation, and when I graduated from that, I ended up being an archivist at Democracy Now!, an organization with no film at all, but a lot of early digital formats such as DAT and DV. So, sorry, I might hunch in a little bit because my notes are so small. Okay, oh, sorry, Command plus helps me out. Okay, so just as an introduction to this particular format, a significant amount of humanity-related content was recorded onto these tapes. This was a format developed by Sony, introduced in 1987, and it was used about up until 2005, and then started getting replaced by file-based recordings and CDs. Tragically, DAT has been proven to be one of the least stable magnetic tape carriers for audio content, and there's now a lot of risk of losing this content. Some of the earliest DATs that survive are now close to 40 years old. This is a tape that's really meant to be very small, compact, and cheap, and doesn't have a lot of like robustness for a long shelf life, even under quite good storage conditions. There were a few like bands in the punk scene that were releasing their content on DAT. I think if you go into Discogs, you can see a couple hundred releases. But generally, DAT tapes were used for like field recordings, for mastering. So generally, like if you find a stray DAT tape in the wild, the chances are quite high that it's a unique recording as compared to like an audio cassette, which was used for mass distribution. So the content is often a copy. So this is an example of a DAT player used in professional environments. It has the basic transport controls, some editing control support, and some metadata functions, like you can set the recording date and time and record that into the tape. This is sort of the format that the organization I was working with was using more. This is a DAT Walkman, so this was quite easy to go out and do like field recordings, to do interviews. You know, this format was really meant to be small and portable and more convenient compared to the bulky, more expensive audio recording formats of the day. So let's see, I'm gonna go over here. So as I was mentioning, DATs are kind of made to be small and cheap, and the format is very sort of vulnerable and fragile on the shelf. Really, just as like all tape-based formats, we have to make a lot of effort to transfer the content from the tape to new sustainable formats. So when I first began to address this challenge at my first archival job, I worked with a collection of several thousand DATs and started digging into what the best practices of the day were for preserving this. From what I could find, amongst the recommendations, a lot of these were quite similar to the procedures used for digitizing analog audio tape. In that, I would put the tape into a player, and I would do this sort of dance of hitting play on the DAT player and hitting record in recording software on a computer. And I'd have a little bit of a cabling and an audio card in between. I was trying to do the best job I could, and as I dug more and more into best practices, I'd learn things like I need to make a checksum, I need to be very strategic about my file name, and was learning more and more about like the specifics of making a broadcast wave versus a wave. But as I was getting more and more into putting this into practice, there was just a lot that didn't feel right. The DAT tape itself contains a stream of interleaved audio and metadata that's mixed into frames. It's already in a digital form. It doesn't need to be digitized. The data just needs to be moved from an incredibly fragile carrier to something more sustainable. And the practices I was putting in place that I could find from the community at the time weren't just moving data. It was essentially making a performance or playback of that tape and then recording what it sounded like. So there was quite a lot of differences between the recording I ended up with and the recording I started from. In archives and on the shelves, often our media is long separated from their original recording devices. And I was realizing I was working with a lot of media without even really understanding what it felt like to record on these pieces of media to begin with. And I realized that there was kind of a lot of risk and naivete of not like learning the process of using this particular media object in its original recording device. When I put the DAT tape back into its DAT Walkman or its the Marantz audio recorder, I could see I had like on here there's like previous and next buttons. So if I put in a recording, I could like hit next and it would go to the recordings, the journalist's next recording. So if they were going out and recording 14 interviews, I could just jump through them all. And if I changed the display, I could see the recording date and time of each one because it was recording the clock setting as into the DAT stream as it was recording. For the WAV files I was recording, there was none of this navigation ability. It was just a recording of audio. All this sort of navigation, this like chapter data was lost, as well as the recording date and time. And I realized that's made cataloging incredibly hard because if I'm just listening to a continuous audio recording that represents a DAT tape playback, I don't know how many recordings are on it. If one person stops speaking and the next starts speaking, I don't know if I'm listening to a new recording or if this is somebody who's just answering the first person. Whereas if I put it into the original Walkman, I could see, oh, from this second to the next, I'm moving from a recording that happened on Friday to one that happened next Monday. I could really like organize things along a timeline. So in the sort of DAT preservation project I was working on, I think at one point I had a tape that, like on these tapes, you could switch it from 48 kilohertz to 32 kilohertz and record additional audio. So a lot of journalists would change this setting in order to get a greater duration capacity on the tape. So when I was transferring one of these tapes, in the recording software, it sounded fine, but once it got to the sample rate transition, it just sounds like very bad, misinterpreted audio, so you get like all that static and randomness. And I emailed a audio preservation community asking like how to best use this sort of hit play, hit record workflow if I'm dealing with frequency changes. And I got two responses that were essentially that I should use the analog outputs of the deck, like to convert the digital tape back into an analog signal and then digitize that. And at that point, I just kind of had enough of like applying this workflow to DAT. I stopped the DAT preservation project and was like, we really just need to start from scratch because this is not effective digital preservation work at all. So this device ended up being my hero. This is the Sony SDT9000. Often there are some media formats that we work with where they'll be used as two different media recording formats. Like for instance, like a DV tape might record DV, or it might have an HDV recording on it. In a similar way, the DAT tape might be an audio recording, or it could be just like a data archive. These drives were called DDS drives. There were 4 generations of them, and they were kind of like an LTO of the 90s. You could use a DAT tape to back up a whole 1.4 gigabytes onto a DAT tape. You know, the interface on the hardware is a lot more simple. There's just a couple status lights. There's no play or rewind. You can just eject the tape. When you put it in, it automatically rewinds it to the beginning and like kind of skims it to figure out if it's a DAT tape or a data tape. I found a couple advertisings of the DDS format. I really like that the phone number for this company is 1-800-exabyte, and then I did the math, and it would take 83 million DAT tapes to actually store an exabyte. But you know, this was like shipped more and more as a backup solution for folks. So then I finally found felt like I had a choice. I didn't necessarily have to use a DAT player to interpret the tape into an audio stream that I would record. I could potentially use the DDS drive and try to get the data off that. In the job I had at the time at Democracy Now!, I had access to like a volunteer that had a lot of expertise in refurbishing like old computer systems. So he hooked me up with all the SCSI gear I needed, and I was able eventually to get this software up and running called DAT extract. And I was quite thrilled because I was able to get access to all the metadata. This essentially like reads the data off the tape and writes out an audio file in one direction and then logs out all the metadata of the tape in another. So I get all the timestamps for when the stop and start markers are, the recording date and time, and then up in the red where the errors are, I was realizing that every audio frame on the tape has error correction code and a checksum on it. So when the tape is being read, the reader is able to understand if it's reading it correctly or if the tape is so damaged that it can't read that frame correctly. So I'd be able to accumulate that data too. In the preferences of DAT extract, I also realized I could make one file per recording. So if a journalist is going out and doing 14 interviews, I could have them all separated into individual files and know the recording time of each one. So I was really thrilled. This was like a huge improvement from the workflow that I was dealing with initially. I had this system set up in 2004, and I used this Mac G3, which I've never thrown away because it was like the only system where I could get this up and running. So right before the pandemic, I was now working at City University of New York. Had an intern, Veronica Smith, delving into a research project because we wanted to document practices for using data drives to transfer the DAT stream off of tape. So this is the setup we had working. We had this working like a month before the pandemic, and then we all had to go home and we couldn't keep working on it anymore. But essentially, this is a Mac G3, a Subtronics 50 cable plugged into a DDS drive enclosure. The enclosure didn't quite work correctly, so the DDS drive is like stacked on top of that. It was a big, messy contraption, but it worked. And then we really got into Mac OS 10.3 Panther. We had to get the installation CDs. For some reason, 10.2 and 10.4 do not have the drivers for the SCSI hardware. We had to very specifically stay in this, I think it was like a 2007 era, but no, I think it was earlier than that, but like this one specific version of Panther, the brushed stainless Finder windows is where we had to end up. So Veronica's paper is amazing that we published. Like it's the bit.ly CUNY-DAT-paper. But in the appendixes, we were trying to document all the instances of people using DDS drives to transfer DAT tapes, and we were only able to find 5 examples of this, including the Fugazi project, there was a project at Radio New Zealand, and a few others. These were the DAT transfer projects happening in archives, and then we found some instances of them being used by individuals. But we could tell there were not that many people doing this. It was incredibly inconvenient. It was difficult to source any of the material because it relies on a pile of obsolete hardware where a simple cable or adapter might be going for like a few $100s for no reason at all on eBay, and none of this is available to get new. So ended up starting a project of NEDCC. We wrote a grant to make a simpler version of doing this. And what we ended up deciding is to completely throw out the computer from the process and rely on a blue SCSI card. Blue SCSI is an open hardware project made by the vintage computing community collectively. This is an instance of a SD card is plugged into the blue SCSI with a little monitor on it, and then SCSI'd into this very portable Macintosh computer. One of the challenges of running vintage computing is that it's difficult to source a working SCSI drive because they're almost all dead or thrown away. So Blue SCSI is creating a way where you can plug in a little SD card and do the transfer. So this is another example of the setup where, like, right above the mouse is the blue SCSI device connected to the computer. So it's sort of like just swapping out your old SCSI hard drive for a SD card. This project started a mode called initiator mode, where the blue SCSI itself would act as a computer. So I was fascinated by this YouTube video put up earlier this year where somebody was testing using the blue SCSI to transfer data off zip drives, because I was like, this is very similar to the DDS process with a DAT tape. So then I eventually got this up and running. I would love to make a 3D printed enclosure for it, but this is the DDS drive of a DAT tape, transferring it. And then I really want to acknowledge my son, Andrew Rice. Over the summer, he was back from college, and he did the pull request to support the audio mode of the transfers in this software, and was like very thrilled that he was able to sort of accomplish all these goals. The issue to deal with now is that once you transfer the data off a DAT tape, it's in a format that's not really supported anywhere. It's an interleaved audio metadata format. I'm going to skip a couple slides, but this is basically an index of the metadata header. Jean Martinez added support for this data stream in media info. Most importantly, kind of right in the middle, we have IPF interpolation flags, and that is telling us if the data was transferred accurately or not. And then we have the other metadata around it. There is a huge amount of failure of this transfer rate. And the failure is really inconvenient to listen to. This is the same transfer moved from a DAT player and a DDS drive. Transferring it as a data drive, we know that the frames fail, but we get just frames of random bits, so it ends up it's not pleasant to listen to. Whether the DAT player is set up to minimize these by dropping out the audio or adding swishy sounds, so the pleasantness of these two is very distinct. But we also notice when we transfer the same tape multiple times, we'll get the errors in different places. There's a lot of opportunity here to selectively transfer a tape in multiple places and merge them together to Frankenstein one better copy out of multiple bad copies. And truthfully, when we look back at a lot of the archival processes to use data tapes to transfer DAT tapes, use data drives to transfer DAT tapes, a lot of them abandon the process because of these errors. So right now, this project is looking into how to merge together multiple transfers to overcome the errors, or how to add other corrections to try to improve the process. So we're still developing software, the pieces are coming into place, FFmpeg pull requests, media info pull requests, but the 4 parts of the project are to capture the tape, so we'll be able to connect the blue SCSI to a computer to monitor the transfer, to analyze and visualize the results, so you can get a little graph of your transfer and how good or bad it is, to potentially merge together multiple transfers to make one better copy from multiple worse, and then ultimately to package it into a WAV file that contains the timecode, the recording metadata, and the chapter information so that you can recreate the same navigation that would be possible in a Walkman. That's it.
Thank you, Dave. I wonder, are there any questions? We have probably time for one. Okay, you were first.
Thank you for the talk. I would like to know what's the availability on eBay and used market for these DDS drives nowadays.
Oh man, I should be worried after this because the prices are all going to go way up. Generally, whenever I search, maybe there's 10. The prices are a bit inconsistent. I don't know, occasionally you see a rare thing of somebody with a lot of 20 of them, all selling them in a group, but the other components of the project are open hardware or easily available things like the 50-pin ribbon cables. The one part that's kind of irreplaceable is the DDS drive itself, and those, so we've sort of narrowed down the recipe of obsolete materials down to 1, which is about as low as we can go here.
I'm more interested in the data format that you extract, and you mentioned some FFmpeg merge requests. Is it to read the raw data that you extract from the files, and if so, what's the status of that? Because I would really like to be able to play them in VLC.
I'd be happy to talk more to you about this. And yeah, but the pull request that Paul wrote was just written, I think, yesterday or the day before. So I'm he sent it to me privately. I'm not sure if it's even on the mailing list at the moment. But yes, this is a conversation to continue. And hopefully I can give a follow-up on this soon.